What are some of the biggest myths that you see related to cancer online?
One of the biggest myths that I see related to cancer got to be like the same logical thought behind like sugar causes cancer, protein causes cancer, fats cause cancer. The X variable associated with the nutrient that I consume causes cancer. That's the biggest one.
What's up, guys? Welcome back to the Dr. Joey Munoz Show, your go-to podcast for all things health, fitness, and nutrition. I'm your host, Dr. Joey, Nutrition Sciences Ph.D. and founder of Fit for Life Academy. I just finished recording a great episode with my good friend, Dr. Joe Zundell, who's a cancer biologist, and he also produces some fantastic educational content around cancer biology on social media. He's actually one of the first people I met on Instagram when we first started making content, probably around 4 years ago now, and we got along really, really well. And I'm so happy to call him a close friend, and I'm so happy that I was finally able to get him on the podcast this week because we've been trying to schedule this for a while, but our schedules just have not lined up. Joe is an absolutely fantastic person, but also a fantastic educator. We talked a ton about the intricacies of cancer with relation to nutrition, exercise. We did some myth busting around cancer and nutrition as well. There's a ton of myths around cancer. I'm sure you guys have heard people say things like sugar causes cancer or protein causes cancer, and we did some debunking around those as well. So with that said, let's go ahead and hop right into the episode. I hope you enjoy. The man, the myth, the legend, Dr. Joe Zundell. How are you doing, my man?
I'm good. How are you, Dr. Joey Munoz?
Doing great, dude. Did you like
The
that
man,
intro?
the myth, the legend. It's ridiculous.
I was practicing before we got started.
Hell of an
I was
introduction.
I was debating mentioning the Dr. Joe squared, but I figured it
Yeah.
probably wasn't the appropriate introduction for this episode.
Yeah. Not many people I think would know that. That was back when we each probably collectively had 2,000 followers.
Dude, those were the times. Remember when we were sipping on some bourbon doing a live Q&A?
Yeah. What, 2 years ago? Two and a half, almost three,
At
maybe.
least. I was still in Tallahassee, so it must have been at least 3 years ago.
Yeah. Man,
Yeah,
time flies.
time does fly. And dude, thank you so much for being on the podcast. This is an episode that we should have done a long time ago, but finally we are here doing it today, and it'd be a really valuable episode. I've been trying to have people who are experts in different um, diseases in particular and talking about the relationship between exercise and nutrition and those specific diseases. So I'm really excited to do this episode because I think cancer is something that we're all familiar with. I feel like we've all been touched by this disease to some degree or another, and there are so many um, maybe questions that people have, but also myths that I know we'll get into here. I want
Yeah.
to start the episode though by getting to know a little bit more about you, and I know a lot about you, but so the audience gets to know a little bit more about you. So
Sure.
if you don't mind, maybe just sharing a little bit about your background, how you got into the field, what was your PhD on, and then we'll start the conversation after that.
Sure. Yeah. So a little bit about my background. I guess I've always been interested in biology. Initially, I got into science to do marine biology. And I did initially go into school for marine biology when I was, in school in Florida. But the whole marine biology track didn't necessarily work out. It's a really hard field of study to get into, largely because there isn't too much funding. And if you don't have the appropriate context, like a lot of fields of study, it's really hard to get into a particular area of research. So I had a really tough time to getting into marine biology. But also, I found that due to personal circumstances with my mom having esophageal cancer and eventually passing away from it, I've always been drawn to, especially after she got sick, I've been drawn to biochemistry and molecular and cell biology, especially in relation to diseases like cancer. So after the marine biology thing didn't really work out, I had trouble getting in the field despite taking a variety of marine ecology courses. I eventually got into internships at the Moffitt Cancer Research Center in Tampa, and that basically sparked my research career in cancer research. And then from there, I initially went to school. I got my bachelor's in biology from a small school just outside of Tampa, Florida, at St. Leo University. I got my bachelor's of science in biology. Um, but towards the tail end of my undergraduate work, I became more focused in doing cancer biology research, in relation to the Moffitt Cancer Research Center. After I had graduated undergrad with my bachelor's in biology, it was really hard to get into a research market. And it took me some time, but I eventually did land a technician position at the Moffitt Cancer Research Center, studying chronic lymphocytic leukemia and mechanisms of what's called the endoplasmic reticulum stress response in promoting leukemias, or a type of leukemia called chronic lymphocytic leukemia. And that position basically moved me to Philadelphia, because that lab we were at Moffitt for a relatively short period of time. We moved to Philadelphia. And then once in Philadelphia, I learned about this graduate school program at the University of the Sciences, which no longer exists anymore. It was right up the street. They had a PhD specifically in cancer biology, partnered through the place where we had moved to, which is the Wistar Institute. So the Wistar Institute and the University of the Sciences had a PhD in cancer biology program. And, I applied, I got into that program. And my thesis work largely focused on ovarian cancer, but mostly a specific subtype of ovarian cancer called ovarian clear cell carcinoma. And I actually ended up discovering that the ER stress response that I had initially studied in chronic lymphocytic leukemia was also implicated in ovarian clear cell as well. Although completely unintended, I ended up studying ER stress for, the duration of my graduate school work too, and ended up publishing that work in the Journal of Cancer Research, through my thesis work. So I guess the rest is history.
The rest is not history because you're still doing a lot of work.
Yeah.
Do you mind quickly explaining what, because I think this will give a little bit of insight to the listeners to understand like the complexities behind cancer. What is ER stress? Why is that important for cancer? What are the mechanisms there? And I'd love to know a little
Yeah.
bit more in detail, like what did you actually study in your PhD and how did you come across that?
Okay. So ER stress, ER stands for the endoplasmic reticulum, which is an organelle inside cells that, has a variety of different functions, whether it's maintaining calcium storage. The smooth endoplasmic reticulum in most cells is a big site of calcium storage, but is also very important for protein folding. So a lot of diseases have associations to, protein aggregate formation or improper protein metabolism. And a lot of this stems from misfolding of these proteins in the endoplasmic reticulum, because proteins are synthesized at the surface of the ER, and then they need to be folded properly for them to be able to perform their functions inside the cell, either from like a metabolic perspective, if they're enzymes, or even acting as scaffolds to regulate protein-protein interactions, or even protein DNA interaction. So they're very important when they're folded properly. If they're not folded, it can lead to aggregation and a variety of other problems in the cells that eventually can lead to diseased phenotypes like we chronically see in cancers, or even Parkinson's and Alzheimer's, those diseases that are often associated with aggregated proteins. So my goal was to study this thing called the ER stress response. And so when you have an upregulation not upregulation, but when you have increased amounts of unfolded proteins, this triggers something called the misfolded protein response, which is directly related to ER stress. It's essentially these misfolded proteins, they cause stress in the ER, and there's a response to be able to deal with these misfolded proteins. So this response eventually results in protein chaperones being increased in expression to interact with these proteins to fold them back to their appropriate form. And if they can't be folded, the cells will then be committed to dying. So oftentimes, this is a normal biological cell process. Right now, you and I both have ER stress going on inside of our cells, but we have chaperones mitigating the folding of our protein. But in diseases like cancers, they can often utilize these stress responses to favor their own survival, because the overall goal of this stress response, the endoplasmic reticulum stress response, is to maintain cell survival. So basically, cancer cells have hijacked this normal mechanism that normal healthy cells use to favor their own growth and survival.
And how is that related to the particular type of ovarian cancer you were studying?
So it's also partially related to what I was studying in chronic lymphocytic leukemia as well. The
Okay.
ER stress response, despite me trying to simplify it, it's separated into three molecular arms of protein contributors that mediate the response. So there's different pathways, if you will. So in biochemistry, we learn about all these different proteins that interact with each other to exhibit a specific outcome in relation to cellular health. In the ER stress response, there's these three arms. There's the IRE1 XBP1 pathway. There's the ATF6 pathway, and there's the PERK pathway. And each of these pathways, there's sensors on the surface of the ER, and they maintain a bunch of downstream reactions that basically either tell the proteins or the cells to stop making protein or halt protein translation, um, or upregulate chaperones. So the one that I frequently studied was the IRE1 XBP1 pathway. And so there are inhibitors against IRE1, which is an RNase, which makes XBP1 a transcription factor. If I inhibit the RNase from making the transcription factor, that transcription factor can't do its job. And then you have too much stress buildup, and this typically pushes the cells towards cell death. That's basically where my work focused on from a cancer perspective, such that, inhibiting this ER stress response in cancer cells pushes the cells towards to dying. And we found that in chronic lymphocytic leukemia. I found these pathways to be upregulated in the type of ovarian cancer that I studied, again, such that inhibiting that pathway was effective. Does that make sense?
Yeah, no, totally. I mean, it makes partial sense to me. I'm sure some people are a little confused, but that's
Yeah.
okay.
I mean, it is intrinsically confusing, and it's really hard to simplify because there's a lot of moving parts. I think there's, a lot of people assume that our job is very binary as cellular
Mhm.
biologists, but the hardest part about my work studying ER stress has been trying to prove that what I was seeing was specifically because of ER stress. Because, when you publish papers, you're showing a specific time point of a given outcome. And oftentimes, most often than not, everything in life is very dynamic.
Mhm.
So it's really hard to capture a specific phenotype in a given time frame to say that this is the thing that's happening and this is going to be beneficial. So I think also people need to understand that it's really confusing and it's really hard work.
Yeah, no, totally, man. And as you're sharing this is a little unrelated, but I was really reflecting back on some of the courses that I took during graduate school during my PhD. And it's just crazy to think that all these things are going on in our body simultaneously.
Yeah.
And you're talking about one particular pathway, and there are hundreds of thousands, if not millions, of different pathways all occurring
Yeah.
simultaneously, and they all
Yeah.
occur the way they need to occur for us to live and be functioning humans. It's kind of mind blowing, man. It's kind
Yeah.
of mind blowing. It really is.
Yeah. I mean, for me,
Um,
it's the same sort of argument for those people that try and demonize autophagy. Actually, one of the outputs of the ER stress response is to regulate autophagy. So it's like, we can sit here and point at one pathway and try and, explain how important it is in a given biological process, especially in disease. But realistically, as we've pointed out, even just through this, 10-minute discussion, all of these things are overlapping at the same time. And that's, it's really hard to convey that to people. But it is just intrinsically complicated.
yeah, and I think where people lose a little trust too is when people who are actually experts like yourself say things like, I don't know, or we're not sure, or we don't really know, or it's complicated. Because people inherently think that experts know everything. And
I'd
it's
love to.
actually the complete opposite. Yeah, yeah,
Yeah.
I would love to do, but then I think our brains would probably explode.
Yeah, I mean, there's something to be said about not knowing stuff though too, because you know, the more we go through our education, I think it's important for people to realize that the more I learn, um, the more I realize I don't know about stuff.
Yeah.
And I think anybody that claims that they have 100% understanding of a given process is just a complete idiot. Like there's no other way to sugarcoat that.
Yeah. I always try to tell people, like, when it comes to research, and I think this is a phrase that's used by researchers often. At least my professor always said, it's like when you answer one question, you like realize there are 10 more unanswered questions.
Well,
You almost like never actually get closer to the true answer, unfortunately.
yeah,
You know what you just said there about like realizing how little we actually know, the more we know. It's important to be humble about that too, man. Um, I when people often ask me like, "How do you know who's a good source of information? Who's not?" I think one of the biggest pieces of advice I try to give people is just like listen to how much certainty people talk with. If somebody is like 100% certain about everything, probably at the very least a red flag, right?
yeah,
I was just I had to check myself yesterday. We were with family, and my wife's father, so my father-in-law, came up to me and he was like, "Joey, do you think there's any benefit to like what people talk about like going a whole day, 24 hours without eating like a whole fast?" And like my immediate response was just to say like, "No, like there's no benefit." And then before I said that, I really thought about it and I'm like, the truth is I don't really know. And the truth is, I don't think we really know as a scientific community, like if there is or isn't a health benefit, and if there is, to what extent, because it hasn't really been well studied in a controlled setting. So I tried explaining that to him, like to the very least, we don't know.
yeah,
And it's hard to say those things sometimes because like you have an intuitive sense, right? You have an
yeah,
intuitive sense of like, no, it's probably doesn't really do much, but like your intuition doesn't really mean much just because you're a so-called expert in a particular field, right? How many people are wrong all the time, even though they're experts in a particular field?
yeah,
And then it's hard to convey that because, you know, I was talking to him, I'm like, you know, we don't really know because we don't have the research to support this. And he was like, but we do know because there are people who fast all the time and like they're healthy. And then it goes into step two of like explaining the way research is conducted and all that, which could be, I mean, you can't do that in a short conversation with
yeah.
somebody.
And
Hard, right?
it's also disheartening though too, because you realize the limitations of what scientists can realistically do. And
Yeah.
so then it's also not shocking that people go to alternative sources of information to get immediate answers to their problems. But realistically, those people also don't know. They're just confidently speaking about things that they don't know. So
Yeah.
the fact that you had the wherewithal to step back from your own internal bias and say, realistically, we don't have the answers to say the importance of a 24-hour fast is an important testament to not only your character as a scientist, but should also be an indicative factor and primary factor in determining who is willing to determine fact from fiction. And people also need
Yeah.
to understand that too. It's okay to not know stuff, and it's incredibly uncomfortable to not know stuff.
Yeah. The saying, I think one of the most powerful things, maybe not, maybe that's an over exaggeration, but the skill of learning how to say, I don't know, is a difficult one, right? But it's
Yeah.
so important. It's so important. It shows that you're a humble person. It shows that you're actually more interested in knowing the truth than like just being right. It's the same as saying I'm sorry. It's
Yeah.
also difficult, right?
Yeah.
Admitting that you're wrong is difficult. And I wish more people were able to do that, honestly.
Yeah. But I think, not to put a lot of importance on our PhD training, because we do both have PhDs, but there is some semblance of importance behind a structured learning environment. So as an example, we go through our entire careers, on a structured learning path. We learn how to critically think, and we eventually obtain our PhDs. Arguably, the obtaining of a PhD is the essential or development or really strong development of critical thinking. As an example, I was in my thesis, giving my talk, defending my thesis. And at the end of a thesis presentation, you have to stand in front of your committee and basically defend everything that, for me, you've come up or you've, discovered over the past 5 or so years of being in grad school. And one of my thesis advisors at the time, she had asked me a question. Dr. Maureen Murphy is one of my favorite mentors when it comes to anything cancer biology. She asked me a question about my thesis work that, realistically, I didn't have the information to answer, but she asked more from a speculative output. And I stood there kind of like, a little bit scared and shocked, and she noticed I was confused, and she stepped back and she's like, "Listen, a big part about being a scientist is admitting when you don't know something." And she's like, "I'm not asking you because I assumed that you knew the answer to that question. But if you don't know, just say that you don't know and move on, you know? That's going to be more telltale of somebody's quality as a scientist than somebody who just bullshits their way through a talk, which we've seen scientists do. I know you've probably been in seminars where you can see that someone's totally bullshitting their way through a question. It's often better just to say, "I don't know." You have that person gets more respect, I think, from an audience when they say that.
Yeah. And it can be incredibly awkward too when you realize that the person is bullshitting.
Yeah.
Like uncomfortable for everybody. I was thinking about a specific situation where I was in another student's thesis defense and it was just like not going well. And I'm sure you've experienced this too. Sometimes, the nature of like mentors and a committee, they can pick up on it quicker than we can, obviously, because they've worked with the person for years.
Yeah.
And when they pick up on that, they almost like dig deeper and start asking more difficult questions.
Mhm.
Dude, I've been in those situations before where I've been observing it and like I start to feel awkward in my head. I'm just like, just say I don't know. Just say I don't know. It's
Yeah.
okay.
Or you hold up a paper sign just says, "I don't
Yeah.
know."
Yeah. You mentioned something really important that a PhD is really like, I wouldn't say the ultimate credentials or whatnot, but of like being able to think critically, right? I think that's the most important component because oftentimes like people have asked me for what I do, is a PhD worth it? Or what did you get out of doing a PhD? And if I were to summarize it into one thing, it's not like the information that I learned,
Mhm.
because you can learn the information, right?
Yep.
You can just read stuff and you can learn information. And actually, there's a ton of people in our space, in the nutrition and fitness space specifically, that are very, very well educated. They don't have a PhD, right? Jeff
Yep.
Nippard is a perfect example.
Mhm.
Just somebody who cares about learning, and through the process of learning, I also think you learn how to think critically. But I always tell people the one thing that I take away from the PhD more than anything else is the ability to think critically, yes, but also the ability to be skeptical about things and think about things from a slightly different perspective.
Yeah.
Because you're forced to find holes in things, right? That like the thing, and this is the way that I try to explain it to people, because I didn't know what the hell a PhD was before I went into graduate school.
None
Honestly,
of us
even my
did,
first year of
man.
my master's, I didn't even know what a PhD was. I thought professors just taught, and that's what professors did. And that's like the smallest part of their job. But it's before you do a PhD, you are a consumer of information,
Mhm.
right? You go to class, they give you information, you learn the information, and then you are tested on the information. And when you're doing a PhD, you're a producer of the information. So you have to actually seek out things that we don't know. And that's really, really difficult, right?
Yeah.
So for sure, I think the most beneficial aspect of doing a PhD is the ability to really learn how to think critically, think differently, be skeptical of things. And it's helped me a ton on the business side of things too, in the sense of like being creative about finding solutions. And another thing is being resilient, right? How many setbacks do you have during your PhD? Probably too
Ooh.
many to count, right?
Yeah.
And
More than the
what's one thing you
positive.
don't? Yeah, you don't give up, right? You like, there was a problem, rather than being emotional about it, although emotions come into play every once in a while. You're analytical about it. What did I do wrong? How can I test this in a slightly different way? How can I improve? And you use the scientific method almost at a micro scale to improve what you're doing incorrectly. And it's a really great way to deal with setbacks. And I've taken that into my personal life and business and everything, and tried to apply those same principles, because the way of thinking really applies to, I think, everything you do in life, honestly.
Yeah. And I think also there's something to be said about the importance of dealing with your emotions in research too. I think there's this sentiment that a lot of people think that scientists are these cold, calculated individuals that just go in lab and we do science and then we leave and we just say everything is completely objective. But man, I can't count the amount of times that I've cried over a bad result. Like it's absurd. It's an absurd amount. It's got to be over 100 times throughout even like even now. Like when you get a bad result, there's nothing like it because so often because science is so complicated, you can't pinpoint directly where something went wrong.
Yeah.
And so even troubleshooting it's an absolute bitch. So I think people need to understand that, there's a strong sense of dissociation when it comes to doing our work, but it's important for us to recognize the emotions that come with doing our work as well. Because actually, I think that the emotional aspect has made me a better scientist, especially in the cancer space. An example of that for me would be, I've worked with a lot of mouse models, and doing mouse work is not only very tedious, but you're working with a living organism. And so a lot of people think, like scientists, they go in a lab, they work with mice, and we perceive them as just a tool. But I've never thought of working with mice like that. I've always worked with mice as though it was like a human being. And so even like I get a little bit choked up now thinking about it too, because the amount of mice that I've given cancer to try and take it away, which seems somewhat paradoxical. It's sad to see that cancer progress in a living organism, even though it's a tool. And so oftentimes when an outcome in an experiment that I've spent so much time developing,
Mm.
it doesn't go as I hypothesized initially, and all of those mice have gone into that study, and you see them go through this disease, it's hard to go through. And I spent
Mm.
a ridiculous amount of time, even just like I would go down there and pet my mice to make sure that they were okay, because there is some sort of stress component
Totally.
outside of what I was physically studying in ER stress in terms of treatment response, even at a clinical level. So, just trying to make sure that the mice were as happy as possible given this shitty situation, um, was an integral part of me being a scientist and doing my due diligence as a scientist. Does that make
Yeah.
sense?
100%. So most of my work was clinical work. So we work with humans for 90% of our research. I worked on one animal study and we were working with hamsters. And I only worked in that study for about 6 months.
Hmm.
And I totally feel what you're saying. My first experience, I walked into the lab, my professor was um, removing the ovaries from all the hamsters.
I did that
And
regularly in my models.
dude, I had to step out of the room after like the fifth one because it was just kind of mind blowing to see him just anesthetize the animal, remove the ovaries, and next one. And it was just like, it almost seemed uh like a factory with these animals. It was definitely very shocking. And then to see the animal just like wake up and it's perfectly fine.
Yeah.
Um, it was it was definitely a wake up call to like what it's like to work with animals primarily for all your research. Because obviously,
Yeah.
do you work mainly with animals or do you do a lot of cell work as well?
So I've done both. Um, so I don't mean to be like cocky here, but I am a bit of a jack of all trades in terms of in vitro and in vivo work. So I've worked with most cancer cell lines. Well, not most, but a ton of different cancer cell lines. I've got some liver cancer and breast cancer cells culturing right now in the lab. I frequently take pictures and I put them on social media, but I've worked with a lot of mouse models as well. And a lot of that has been also ex vivo work. So taking tumor samples from humans and cultivating them in the lab. So that's called ex vivo. But, you mentioned ovarian models. Like I said, my thesis work was on ovarian cancer. So a big
Mm.
portion of that work was we had not spontaneous. We had a cancer model. Basically, um, you would inject a virus into the bursa of the ovary. So you needed to anesthetize the mice. Um, and it was a surgical team. It was me, the guy who did the surgery, and somebody who did the anesthetic. So someone would anesthetize the mice, they'd fall asleep. That mouse would then be not opened up, but you can cut a tiny hole in the back of
Yeah,
the mouse, and you can
pretty
kind
much
of
opened up.
no. So we had a really good surgeon. It's intrabursal injections. So you make a really tiny incision,
Mm.
and you can pull the bursa of the
Mhm.
ovary through that tiny hole. And so he would hold it steady, and I would inject the virus, which is a Cre recombinase virus, into the bursa sac of the ovary. it was like 2 microliters. It's something really small. And then, he'd pop it back in the hole, and then we would, clamp it shut with a staple. Um, and then the mouse would wake up and be completely fine. It's kind of like that what you were saying earlier.
It's
But
crazy.
but then once you inject that virus, after about 3 to 4 weeks, these mice will essentially form tumors in the ovary that you injected, and then the other ovary would be fine. So it's unilateral injection. Um, and so basically that virus would knock out the protein that I studied, ARID1A, and overexpress PIK3 kinase, which is involved in cell growth. You're probably familiar with the PI3 kinase pathway in relation to diseases like cancers. But both of those events at the same time would generate ovarian clear cell carcinoma characteristics in these mice. They develop tumors, and then after about 4 to 5 weeks, we would start treatment with our drug to see if it changed the rate of growth of the tumors. And so that was my thesis work. But even now, I work at a radiotherapeutic company, and so now the animal work that we do is different because it's from like an imaging and radioisotope perspective. So we use, radio labeling and CT scans, or positron emission tomography scanning, to determine, where our molecules that we inject are going as either a diagnostic or a therapeutic. It depends on the type of radioisotope we're using. But, the same sort of animal models are used. It's just the questions we're asking are different, and that shifts how we use the animals.
Yeah. That's really cool stuff, man. Question here. How did you get into making content on social media? I know this is a little bit of a shift in the topic, but the reason why I
Right.
ask is because most people that have your background and your experience do not post content on social media, right? And I'm sure you and I both know so many wonderful and intelligent researchers, scientists,
Absolutely.
where it would be very beneficial if they created content and educated people, right? And maybe
Yeah.
that's where your interest came from. But I'd love to know why you decided to make content on social media.
Well, you know a little bit of my backstory because, again, we met each other many years ago, and we started at the same time, kind of teaching each other, how to use Canva and color schemes and fonts and all that stuff.
Hey,
Uh,
dude, what font are you using for your post? What
it's the
colors?
same as it's the same one, dude. The Bebas New and
Yeah, no, I know.
Montserrat.
I'm joking because those are some of the conversations we used to have early on, which is absolutely hilarious.
Yeah, but we discovered that, and I've used the same font since we, I guess, had that little master class between us about font pairings and marketing and all that stuff too, or even just making things look nice. But
Yeah.
so there's a bit of a double-edged sword here in terms of why I got into content creation. The first one being that I've always wanted to have my own lab, and I've always wanted to be an educator. So I really enjoy doing my best to try and simplify things such that as many people as possible can understand my field of study, as complex as it is. And then the other edge of the sword is that I really just love making stuff. Like I'm very creative. And so, even playing with color schemes and fonts and pictures, and even integrating cat pictures into my posts, a lot of it is I just really enjoy making stuff
Yeah.
and making it visually appealing, because I also know that if I can make it visually appealing and educational at the same time, I'm likely to solve the problems that I seek to solve in regards to misinformation related to my field of study online. Because let's face it, you go online and you see a million people talking about cancer, but very few of them having sufficient expertise to discuss cancer biology. And so I find myself most days competing with people that don't know what the fuck they're talking about online, and hope to God that people can find my page. And so
Yeah.
I miraculously, to this day, still shocks me that I've been able to garner a significant audience where I have now about 44,000 followers of people that are actually now trying to learn cancer biology, and they look forward. I hope they look forward to me doing my best to break things down for them. So I'm meeting the need in terms of dealing with misinformation, but also making it fun for people to enjoy. Um,
Yeah.
And a lot of my inspiration, sorry to keep rambling, a lot of my
No.
inspiration for this also comes from one of my favorite YouTube channels. I've shared it frequently on my story. It's called Kurzgesagt. It's like a German um, YouTube channel, but they break down literally every scientific topic, whether it's like ecological sciences, evolution, cancer biology, immunology, uh, prehistoric extinction events. They break down everything, black holes, how they work. They utilize such amazing imagery and graphics, and they simplify things in such a way that is truly beautiful to me. And so that's what I try and mimic on my own platform,
Yeah.
although poorly in comparison.
No,
In
you're
my
doing a great job, man. Your content's fantastic. And
I'm not asking
how
for validation. It keeps me humble. I know I can be better is my point.
I was gonna ask as a joke, what percentage of your audience do you think follows you just for the cat pics?
Probably 100%.
For those of you guys that don't know, if you go on Joe's profile, he includes a picture of a cat on pretty much every single one of his posts. Not on the
Yeah.
reels, but on the swipes, right?
Well, sometimes my cat joins me in the reels, and I can just,
Yeah,
shove
yeah.
him in front of the camera.
I remember when you first started doing the cats, and I was like, "What's Joe doing with adding cats to these?" And then it just like became a
It
thing
became
in
a
all your
thing.
posts, and I'm like, now it would be weird if you didn't include pictures of you stuff.
The fact that people come to my page largely for cat content is hilarious to me. But it also means that I think I've done a good job. Because I've also learned from a marketing perspective, it's important to have something that draws people's attention to something. So if I can get them there with like cute cats,
Yeah,
cute imagery, it's the same way that YouTube channel uses like little cute graphics of birds. If I can get them there with something cute, and then they're like, "Oh, this is actually really interesting." You know,
it's important to make things fun
it's also a
because
little bit manipulative, and I feel bad, but fuck it.
no, it's important to make things fun, man. It's important to make things
Yeah,
fun. If you think about even like, I can think about some of my favorite professors. They were not monotone, boring educators,
right.
right? They were engaged. They were exciting. They themselves were really interested in the stuff they were talking about.
Yeah,
They made learning fun. And I think that's a really important point. And I think that's actually one of the reasons, could be wrong here. I think there are a lot of reasons why, but there's such a big disconnect between science being produced
Mhm.
and then like the knowledge of the general public.
Yeah,
Uh, I think part of it is because uh, the way that science is produced and published, right? Like behind a
yeah,
paywall. I think that's one aspect of it. But I think too, like a lot of scientists are poor communicators. And that's just the harsh truth, right? Like a lot of scientists are poor communicators, not in the sense that they don't know how to talk about what they're doing, because obviously they know how to talk about what they're doing, but like it can be quite boring, or they don't know how to explain things simply, or they don't know how to talk
yeah,
to somebody who doesn't actually relate or know about anything that they talk about.
yeah,
And so there's a big disconnect there. And that's why I do think it's so important for people like you to do what you're doing, because only somebody like you can understand the science at a very deep level, but also explain it to the general population, which is really important, right?
yeah,
And it's funny because I felt a little bit of imposter syndrome is the wrong term, but I remember finishing my PhD and going into like this coaching space and helping people with nutrition and like talking about stuff online. I was like, man, what did I do a PhD for? Right? Because like you don't necessarily need a PhD to do this stuff.
yeah,
Um, but then it's like, but somebody who doesn't have that education wouldn't be able to do it in the same way. And I do think it's really important for there to be a field of science communication for the
yeah.
general population. Because think about it, how else does somebody get information about new science that's being produced if it's not from people like you and I?
Well,
It
the
would
thing
be
is,
from media, right?
yeah,
Like news channels, and you know how shitty those are.
yeah. No, I think the thing that's important to point out though here is the importance of good mentorship, and I think one of the reasons why you and I are relatively good communicators in the scientific space of the fields that we discuss online is because our mentors instilled in us the importance of being able to break things down with the intent to try and get a large audience to understand the information that we're trying to convey. Because even within our own field, there are things that I could start discussing that would just absolutely go way over your head,
Yeah.
despite both of us being PhDs. So it would be really important for me to be able to break things down in a way, even amongst PhDs, for us both to understand if we're to collaborate or if I'm to educate you on a particular topic that you're interested in. The same is true for laymen. It's just that, laymen or lay people need a greater breakdown of that information. And that takes a ridiculously strong understanding of a field of study to be able to break something down even further than what is typically conveyed between two scientists talking or multiple scientists talking, because that level of critical thinking is very different. And it's not to say that lay people are stupid. It's just that they don't have any expertise in the field that you're studying compared to somebody that
Yeah.
has developed that critical thinking that we typically exhibit in the sciences.
Yeah. So I forget the YouTube channel. I used to follow this YouTube page, and they had a couple of videos where they would bring an expert in a particular field.
Mm.
Let's say like a leading expert in AI or a leading expert in uh, quantum physics, right? And they would explain their field of topic, their field of expertise to uh, an elementary school student, a middle school student, a high school student, an undergraduate student, and a graduate student. And they would actually
Amazing.
talk to that person. It's not like picture yourself talking to a kid. They would actually talk to a kid and explain it. And it was so fascinating, man, because they would do a really good job. Like when they were explaining AI to an elementary school kid, it was essentially the exact type of language that you would need for a kid to understand it to the best of their ability.
Yeah.
And then sometimes it's funny because I would watch these videos and I know that this person is an expert in the field. And when they're talking about it so simply, it makes them seem like they're not an expert because they're talking about it so
Right.
simply. And I would watch the whole video and then they would start talking to a PhD student and it would be completely over my head. And I'm like, wow, like this is really fascinating. This person's obviously a really good communicator, but also really knows their shit. Right. And
Yeah.
that was one of those videos were some of the inspirations that I used for like how I try to communicate online because I used to try to, when I first started like make things somewhat complicated because I thought it would make me seem smarter.
Right.
And then I was like, this is just to stroke my own ego because what really matters is the other person listening actually understanding. And now I try to make it simple as possible. And sometimes it
Yeah.
backfires because I leave out some nuance that should be included. It's
Yeah.
hard
It's
to find
never
that.
perfect.
It's fine to hard that balance.
Yeah.
It's hard to find that balance. I think I just said something totally different.
It's fine.
Dude, so question for you. Since
Sure.
you're in the online space on social media, creating content about cancer, what are some of the biggest myths that you see related to cancer online?
Yeah. So obviously, one of the biggest myths that I see related to cancer, it's probably got to be like the same logical thought behind like sugar causes cancer, protein causes cancer, fats cause cancer. And we've actually, I think, even collaborated on some of these posts together in the past to try and explain the appropriate nuance associated with these topics. So the X variable associated with the nutrient that I consume causes cancer. That's the biggest one, and it's honestly it's so false that no matter how simply I break it down for people, they're like, yeah, but you've still shown us that it can fuel cancer cell metabolism. So it might not cause cancer because it's not a carcinogen itself, but it's still fueling cancer growth. So wouldn't it still behoove oneself to not eat carbohydrates, to not eat protein? Because if we fixate on the mTOR metabolism, or if we fixate on the insulin signaling or the insulin spikes in X cancer, we can say, oh, if we cut that resource out, it's going to reduce cancer growth. But more often than not in these cases, it's really important for me to convey to people that in cutting out these resources, you're more likely to impact healthy cell metabolism than you are to impact cancer cell metabolism. So I find that people have this trouble discerning that life is really all about balance. You can hear your favorite charlatan talk about, homeostasis and all that stuff online, but they don't really have a good grasp on it if they're telling people to, you know, hyperfixate on their insulin spikes because of insulin's roles in promoting growth in cancer, or hyperfixating on mTOR metabolism because of leucine, isoleucine, and valine's roles as anaplerotic fuel substrates. Look at me using big words for cancer cell metabolism, right? If I wanted to sound smart, I could absolutely do it, but that's not the point, right? The point is trying to convey these simple components that life is truly more complicated and it's much more in disease states than just sugar fuels cancer, because sugar also comes in many types. But sugar is also super important. I studied ER stress. A lot of proteins need to be modified by sugars for them to perform their functions in cells as well. So if we cut out those sugars, we're also impacting metabolism super negatively, not even just from a fuel perspective, but from just like a protein biology perspective. So those things are really just very complicated.
Yeah, it comes down to throwing around the word causes, right?
Right.
It's
Yeah.
causes.
Correlation and causation, right?
Yeah. Let's do quick 5-minute, as simple as possible, myth busting on each one of these, because I want people to understand why some of these things just aren't true. Okay.
Got it.
So we'll do sugar causes cancer. Where does that come from? Why is it not true? As simply as possible.
Sure. So the sugar causes cancer thing comes from this observation that carbohydrates like glucose, when we break down the mechanisms in papers, they promote cancer growth processes. Why is it not completely true? It's not that it's untrue. It's why is it not completely true? Is because it's an input and not necessarily an output or a total output. So just because glucose is going into the cell, it's being broken down, doesn't necessarily mean that that's the only thing that cancer cell is using to promote its growth. The glucose is broken down into other molecules, which can go into the citric acid cycle, other metabolic processes that can promote growth. So that glucose can give carbon molecules to amino acids, to fat molecules. It's essentially repurposing glucose for other energy needs. And in the cancer space, we call this energetics. So that's just to put that as simply as possible.
Yeah, and in low carb situations as well,
Mhm.
can cancer cells make their own glucose?
Yes, absolutely. So we often see in a good case of this would be, liver cancer. Gluconeogenesis occurs in the liver. There's a variety of different enzymes involved within the production of glucose in the liver, and they can make their own glucose through gluconeogenesis to continue to fuel glucose metabolism, even if glucose is low. So they can break down glycogen as well, that's stored in muscle, shuttle it from the muscle to the liver to fuel liver cancer metabolism, as an example. So even if I exogenously cut off glucose from my diet, I can get glucose from other molecules in my body. And a lot of people don't realize that as well. And that's also one of the really beautiful parts about life is it's extremely adaptive. I think people need to realize that cancer cells were normal at some point. So the biological mechanisms that normal cells have, cancer cells also have. And they can utilize those same mechanisms, whether it's glucose biology, protein biology, fat biology, to maintain their life just as a healthy cell would. It's just the rates are messed up often.
Yeah, and it's this whole idea, man, like people just, it's A equals B, B equals C, C equals D, so A equals D. And it's like, it
Right.
doesn't work like that, right? It's like, oh, cancer cells use sugar to grow? Sugar causes cancer. And
Yeah.
those two things are so distant,
Yeah.
right? The thing is, like, again, the layperson doesn't understand how distant those things are.
Yeah.
Because it's like, okay, you consume sugar. Okay, that's one thing. And now it's like, all right, cancer cells use sugar. But does that sugar get to the cancer cell? Can the cancer cell get sugar from somewhere else? Does the sugar trigger cancer? Like, there's so many questions there. And I
Yeah.
just had 3 short little questions that came to mind. But it's like, these things are actually so far apart. And to connect them is crazy. To
Yeah.
connect them just because we see cancer cells using sugar, it's hard for us to really depict how distant those things are. I'm trying to think of like an analogy that would make sense with like common day things. Um,
I mean,
yeah,
the
I
thing
can't
is
think
not to cut you
right.
off here, but like this is where the importance of communicating this stuff comes into play too, because I mean, we publish these A to B to C mechanisms in papers because that's what enables us to publish in these big journals. And I spoke about this on Drew Purehit's podcast, was that you're never going to get a paper with just like a phenotype. You're not just going to give a drug and watch cancer cells die. And the journal is going to be like, okay, that's it. You have to
Yeah.
have some semblance of a mechanism. But whereas we are qualified to determine that mechanism and say, oh, this is realistically more complicated, but this is a small fraction of the picture. Somebody else who's not in my field will come in and look at that paper and be like, A, B, C, that's it.
Yeah.
That's not it.
Yeah.
That's not it at all.
Great
That's
point.
one of a million pieces of a picture that we can target either pharmacologically or maybe even diet.
Yeah.
But if we do that, there's consequences. It's
Yeah.
never,
People
never
don't
binary.
understand the concept of redundant mechanisms as well.
Yeah.
Like one thing may be contributing to the development of cancer. And if you turn off that thing, another thing might turn on that like causes the same thing to happen essentially, right?
Yeah.
That's why these things are so complicated. Um, shit, I was going to say something.
Sorry.
No, it's okay. It was something about mechanisms. Yeah, it's okay. It'll come back. So next one,
Okay.
protein in cancer. Where does that come from? And the question I was going to ask. Sorry, we'll tackle
Sure.
the protein one in a second here. Do you know if there is at least correlational data between populations who consume a higher percentage of their caloric intake from carbs, having a higher risk of cancer, or not really?
So there's correlational data, and it honestly depends on if those carbohydrate sources are coming from. So it's basically like this argument of excess carbohydrates, right? So if I consume a bunch of foods that have added sugars, right, in excess, it's going to increase my likelihood of developing diseases associated with excess caloric expenditure.
Sure.
So obesity, diabetes, common examples. And as such, there's a variety of cancers that are correlatively linked. I think at least 13 that are correlatively linked to cancers because of the metabolic outcomes that come from
Yeah.
people consuming excess calories. It could be because a lot of the foods they're eating have added sugars in them, but it could also be because a lot of those foods have relatively high amounts of saturated fats, especially if they're consuming ultra processed foods, which is, again, a really common thing, especially here in the United States regarding the Western diet, which you've spoken about on your own platform from a nutritional science perspective. But it's not an easy thing to blame sugar intake alone.
Yeah.
As few
And
things
I would assume if caloric intake is controlled for, the ratio of carbohydrate intake isn't independently associated with cancer, is it?
are.
And I bring this up because there are so many like cultures around the world that like predominantly eat carbohydrates, right? And I know it's hard to even pinpoint these things because there are so many differences between the lifestyles of people across the planet, right? It's difficult to pinpoint. I guess my question is like, all other variables controlled, if two different populations consume very similar caloric intake, but one population consumes 60% carbohydrate versus 30% carbohydrate, they have a higher risk of cancer.
So
I don't know if we know an answer to that.
the answer is yes, but it's always going to depend on the types of cancers.
Okay.
So there are some cultures that have greater risks of specific types of cancers because of the foods that are associated with their society.
Gotcha.
A good example I like to give in this regard is people of Asian descent have increased risks for gastric cancers, particularly if you look at the rates of gastric cancers in Japan, largely because of their high amount of consumption of raw fish or even fish in general, but also high consumption of pickled things as well. So it's correlative, and it's not to say that high consumption of fish is going to cause cancer or high consumption of pickled foods is going to cause cancer, but there's something there that the relation to consuming relatively high amounts of those foods as a total of a person's diet can be correlatively related to specific types of cancers like gastric cancers. But it's also important to note that diet isn't just one or two variables. we also have to consider things like alcohol consumption in society, socioeconomic status, how close someone, grows up next to industrial plants, levels of pollutants in the environment, whether or not someone has access to healthcare, whether they can um, fight off infection in their environment or afford to fight off infection in their environment.
Yeah.
Yeah.
And then to take it a step further, the relationship between all of those variables that you just mentioned and genetics,
Yeah.
right? It's it's really complicated, man.
Yeah. Well, even going into a step further into genetics, again, if we look at Asian populations, are you familiar with the flush syndrome that Asians get
No.
when they drink alcohol? So so when a lot of Asian people drink alcohol, they essentially have a genetic many people have a genetic polymorphism, or it's a variation in one of the genes that breaks down ethanol when it's consumed via alcohol consumption. And this genetic variant decreases the rate of breakdown of ethanol when it enters into their body. So it's a two-step enzymatic process, but because it's slower at one step, it increases the total amount of uh, acetaldehyde in their system, which is carcinogenic in high doses. So if they can't clear that acetaldehyde in that second enzymatic step, because the first step, they have a genetic variant that slowed down the reaction, that acetaldehyde will build up in their system and they get that flushing.
Mhm.
So once the body breaks it down, that flushing goes away. But those people are at greater risk for liver cancers because of the reduced rate of that enzymatic potential of breaking down alcohol. So populations like that would definitely want to reduce the amount of alcohol that they consume relative to the rest of the population.
Yeah. Comes back
Genetic.
to that super complicated. I mean, same thing goes. It's difficult when people ask me about like saturated fat and cardiovascular risk because
Yeah.
a big component of it is genetic, and some people are just predisposed to really high LDL and are super sensitive to the negative impacts of saturated fat.
Yeah.
There's people that can eat a ton of saturated fat and their LDL doesn't really change much. And it's why all of these things are so it's like the answer is always it depends. And it depends on what? It depends on like your individual circumstances for the most part.
Yeah.
Um, and that's a tough thing for people to hear because people want an answer.
Yeah. Well, that
And I
just
get
goes back to what we were talking about earlier about like, people need to be comfortable with this I don't know aspect associated with things.
yeah,
Um, and stop searching for answers from people that are just going to give an answer because they want to sell a product.
yeah,
Buy my
yeah,
supplement. It'll help you deal with autophagy because autophagy is bad all around. You want to get rid of the inflammation? Here, consume my leaves. This
mhm,
leaf supplement. It's just leaves from a tree that they broke down. Insulin bad. Consume these leaves.
yeah. Dude, it's funny
Yeah.
because, yeah, like all these things, inflammation is
Nature.
bad, sugar is bad, autophagy is bad. All these things, people are just like bad, 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 and take the supplement to make it go to zero. Like, do you know what would actually happen if you had no cholesterol? If you had no blood sugar? If you had
Your
no
cells would
inflammation?
just go.
You would just die. You would just
Yeah.
die. You wouldn't exist. It's like, it's funny when people talk about things as like bad or good in a black and white context because um, most things have a role in our physiology and we need to keep them within a healthy range.
Yeah.
We're like too high, and most people just talk about like too high being bad, and like nobody talks about too low being bad as well.
Yeah.
And it's important to discuss because, again, like you need sugar in your blood, you need cholesterol. These things are important. You just don't want too much of it. You also don't want too little of it.
Yeah.
But, selling the optimal range isn't as sexy as blood sugar spikes are bad.
Right.
Or take some apple cider vinegar or whatever it is they're selling nowadays.
Yeah. No, and this brings me back to something that I experienced somewhat recently. I went to Dr. Gabrielle Lyons' Forever Strong Summit, and
Mhm.
I was talking to this woman there, and she was like, I'm really just convinced that most of the health issues in the United States are literally just due to chronic inflammation. And so, I had to take a step back from physically imploding because, it's again this I understand where this idea comes from, and it's because online you hear inflammation bad all the time. Um, so instead, I took a step back and I was like, I tried to teach her about the importance of chronic inflammation being bad, But also, if you don't have inflammation at all, you won't be able to live. Like you
Yeah.
need some semblance of inflammation. All inflammation is, it's an ambiguous term that describes immune cells being recruited to a specific site of either damage or pathogenic infection by bacteria, fungi, virus, or parasite. And that's all inflammation is from like a molecular perspective. But once that inflammation is cleared because you've dealt with the damage, you've dealt with the pathogen, you still need some baseline level of inflammation to keep your body healthy. It's like this background level of inflammation that all these cells are signaling to each other to just be on the lookout for potential issues that go on in your body. Too much is bad. Too little is bad. Again, right in the middle is good.
Yeah.
Middle, that baseline middle varies dramatically between people.
Yeah.
So it's hard to say what that optimal range is because there is no optimal for a global population. There's only an optimal for one person. And I can't make a blanket statement without knowing the total inflammatory profile of a single human being. And realistically, nobody could ever know that.
Hey guys, some of you may not know that I'm the scientific advisor for a supplement company called Outwork Nutrition. I help with the formulation of new products to help ensure that they're effective and backed by science. Unlike many other supplement companies out there, we don't rely on exaggerated claims or flashy marketing tactics. Instead, we let the science speak for itself. We take pride in formulating products that deliver real results, helping you achieve your fitness goals in a meaningful way. If you're in the market for supplements like protein powder, pre-workout, or recovery products, make sure to check us out at outworknutrition.com. And as a thank you for being an avid listener of this podcast, use code Joey for an exclusive discount at checkout. You can find the link to our website down in the description of this podcast episode. Remember, our goal is to empower you with science-backed supplements that truly make a difference. Choose Outwork Nutrition and elevate your fitness to new heights. Yeah, totally. And it's, there's some truth to what she said in the sense that like low-grade chronic inflammation is definitely a contributing factor to the development of many diseases.
Mm-hmm.
But inflammation is not the thing you need to target. Right. Because then it's like, oh, okay, now we need to take these things that lower inflammation. It's like, no. Like we need to improve overall lifestyle because this has an impact on chronic low-grade inflammation, which then will help improve or reduce the risk of diseases. But yeah, it's just funny because
it's like, missing the forest for the trees.
Exactly.
Yeah.
Exactly. It's targeting just the last final part of it. You can't just do that. And it's funny. It's like, because people don't understand that inflammation, like you mentioned, it's literally referring to the activity of the immune system. And if you say no inflammation, that means like no immune system.
Yeah.
And
which, you see people have, right? You look at people have autoimmune diseases or people that have literally no immune system or a hyperactivated immune system, and they have horrible diseases.
Yeah. Yeah. Dude, okay, so back to the topic that we were talking about nutrition.
Anyways, common questions or common conversations between Joey and Joey.
Yeah, Joey squared, baby.
Yeah.
Bring
it back.
Protein in cancer.
Yeah.
Where does this idea come from? I'd love to give a simple explanation of mTOR and the difference between mTOR maybe in like a cancer cell versus like mTOR in muscle, right? And why does protein not cause cancer?
Okay.
Try not to give away the answer before you give it away.
Yeah. The protein causes cancer argument stems from protein being made up of amino acids. When you consume protein, those amino acids are digested in the stomach, broken down into single amino acid. Those amino acids can then be used to produce other molecules for fuel in the body. That's just keeping it simple. Mm-hmm. Healthy cells and cancer cells. So if somebody has cancer, there's this idea that if I consume protein, it's broken down into those amino acids, and those amino acids are used to fuel cancer cell metabolism in the same way that people often confuse glucose metabolism. It can fuel tumor cell growth. That's where that stems from. And a lot of this comes from, again, deeply mechanistic works that show that amino acids, if we look at specific like branch chain amino acids, earlier I mentioned leucine, isoleucine, and valine as an example, can prompt mTOR signaling. So there's been some really good research in the cancer space, in cancer models of research, that show that amino acids like leucine, isoleucine, and valine can stimulate a metabolic profile in cancer cells through mTOR that promotes cancer cell growth. So then again, because we have these mechanisms where these amino acids induce mTOR signaling, and that signaling has been causatively linked to promoting cancer cell growth. If I just cut out the primary fuel source, I can stop mTOR from doing its job, and then cancer cells will stop growing. But the truth of the matter is that we've tried to clinically target this process. We can't realistically just cut out those specific amino acids because there's many different types of amino acids, and all of them are used in some way, shape, or form for human metabolism. If I cut out those amino acids, again, same way that if I cut out glucose, you're more likely to affect healthy cell metabolism than you are cancer cell metabolism. So this is where we've tried to develop specific molecules against things like mTOR. So if I get a cancer, pancreatic cancers often upregulate mTOR in their metabolism. If I have a pancreatic cancer patient and I get a biopsy of their tumor and I see that mTOR is upregulated or increased in its expression and activity because it's an enzyme compared to, or sorry, it's not an enzyme, but let's just say it's compared to a normal healthy person, increased. There are inhibitors that can target mTOR metabolism to be more selective than it would be if I just starved that person of the amino acid. So I'm going after the mTOR and not the whole metabolic process. Does that make
Mm,
sense?
yeah, totally. I can assume also, if I could follow up on this, because like, this idea of like maybe consuming low protein, if you do have cancer, might make perhaps a little bit more sense to people. But I'm assuming similar to glucose, um, tumors can get the necessary amino acids from neighboring tissues, correct?
Correct.
Yeah,
Yeah.
because like most of our body is made of protein. And
Right.
I'm sure if like we're not consuming protein, you could probably just steal some amino acids from whatever local tissue there is.
Yeah.
That's the hard part that people have grasping. It's like, hey, cancer uses these amino acids to grow, and we can get these amino acids through our diet.
Mhm.
So we shouldn't get them through our diet so we don't fuel the cancer. But the cancer can just get them from the tissues that are there locally, right? It's like the cancer tissue is still getting the stuff it needs, whether we eat it or not. And like you mentioned, if you don't eat it, you're now robbing yourself of those nutrients that are very beneficial for normal, healthy, functioning cells.
Yeah.
And the cancer cells are still getting what they need. So it's not that simple. Is there any
So,
relationship between protein intake in terms of like maybe rates of survival with people who already have cancer?
so from what I can see, it's typically the people who have, people who consume a lot of protein, both plant and animal. I want to emphasize that this is important because obviously with plant protein comes a lot of things like fiber as well.
Yeah.
From the research, I can see that people who consume high amounts of plant and animal protein um, have greater survival rates when it comes to diseases like cancer. So we can
Mm.
stratify populations of cancer patients and say, are there populations of cancer patients that have different, amounts of protein consumption in their diet? And then, how much of that is plant versus animal-based proteins? And we can see that people who typically consume both plant and animal protein sources, just from a protein perspective, not even like a total nutritional perspective, have better outcomes when it comes to not only response to therapy, but also just overall outcomes in their disease. Because one thing that we see as a cancer patient develops in the clinic is this state of cachexia, which is muscle wasting. So as you point out,
Yeah.
we have a lot of protein in our bodies. Cancer cells can pull protein in the form of amino acids from other tissues. And so oftentimes in later stage disease, cancer cells will outcompete healthy cells, their metabolism, by increasing the catabolism of other tissues to break down the stuff that it needs to grow because it's growing at such a high rate. And the healthy cells are so unhealthy at this point because they don't have enough ability to compete with the cancer cells. So it's almost like they're losing a war
Yeah.
in fighting for glucose, in fighting for protein, in fighting for even fats. And so that's where we see states of cachexia where, late stage disease in cancer patients, they lose an absolute like almost all of their skeletal muscle mass is like gone. And a good example of this is like when my mom was super sick, before my mom had cancer, she was obese. My mom was a hardy woman. And by the end of her diagnosis, she was maybe early before she had cancer. She was like, I don't know, maybe like 200 and something pounds,
Okay.
just relatively fat. But by the end of her cancer, she was 90.
Oh my God.
It's ridiculous. Like it was like hugging a stick figure. And it
Yeah.
was it was so sad to see, but this is, amongst all cancers, this state of cachexia happens 30% of the time amongst all cancer patients. And actually in progressed stages of cancer, even higher percentage, about 80% of all advanced stages of cancer patients exhibit cachexia. And it's because of this hypercatabolic
Okay.
state of cancer cells competing with healthy cells for fuel.
Yeah. Yeah, man.
So
Biology is
eating protein can be very helpful
yeah.
for cancer patients to combat that.
Yeah. So talk about the topic of like what people can do and protein that being beneficial. What are some of the top things? And I think this is a good way to wrap up the episode too. What are some of the top things that people can do to reduce the risk of developing cancer? And I want to emphasize the term reducing the risk because sometimes you hear people are like, if you do this, you're completely eliminating your risk of getting cancer or anything like that. And we all have to understand that like genetics obviously play a role, right? And you can never get your risk down to 0%.
Right.
But in general, what are some diet, exercise, lifestyle related things that we can do to reduce our risk of cancer?
Yeah. So the best thing that I can tell people, and what I've consistently told people, is it's always going to be the basics. You're never going to hear me tout some sort of fancy mechanism or some fancy supplement that people should be consuming to offset risks for cancers. So the number one thing that I can tell people, and it's going to be a group of things, is find any exercise that you enjoy that you can consistently do for the rest of your life. And keep in mind that as you get older, that's going to change. Just be ready to accept and adopt a different type of exercise as you get older to accommodate the fact that you're getting older. In other words, I'm getting old. I can't move the same way as I did when I was fucking 20 years old. So maybe I should stop, powerlifting when I'm 80. But incorporate some form of movement that you can consistently do throughout time to enable good health outcomes. Again, good health outcomes. It's never going to be perfect. You can still get cancer if you have the optimal exercise regimen associated with your lifestyle. Grouping into this, I will also say sleep health is super important. We're starting to, well, not starting to see, we've seen throughout the literature in a strong form of evidence that better sleep health habits are associated with reduced risks, not even for just cancers, but for all disease. So, making sure that people go to bed at a regular time, in accordance to, I can go on a jargon run here and just talk about circadian biology importance, but there are deeply ingrained mechanisms within our body that operate on a specific time scale because humans are diurnal, which means we wake up and we're active throughout the day and we go to sleep at night when the sun is down, light being an important cue. If I try and fight those light cues, which go against my physiology, I'm going to predispose myself for diseases like diabetes, heart diseases, and cancer. So trying to have an effective and consistent sleep schedule, just like you'd have consistent exercise, is just as important. So have a good sleep health routine and stick to it. Obviously, that's going to be challenging if somebody is a shift worker, but it's important for those people to try and not work in shift work positions if they can avoid it. Obviously, that's a luxury and
Yeah.
oftentimes a privilege, especially, for researchers' perspective. My wife is a circadian biologist, so she often has to go do these elaborate experiments in the middle of the night, which goes against her physiology. So exercise can help to offset some of those effects if somebody can't get an appropriate sleep health habit plan. And then obviously just minimize the consumption of alcohol and smoking as much as possible. I'm not here to be people's buzzkill. I have the occasional drink. You'd mentioned at the beginning of this episode that one of the first times we went live, we were both drinking a nice bourbon that we enjoy. Enjoy things within reason, right? Obviously,
Yeah.
chronic consumption of alcohol being a carcinogen, will be strongly associated with the induction of cancers, specifically liver cancers. Um, so yeah, same with, smoking. Smoking is a carcinogen. But if you do smoke and you find it, relaxing or whatever, just try and minimize it as much as possible. I can't emphasize enough. You've said it. The dose makes the poison. Um, Keep it basic. So those are my basically top three, and we can add, regulating um exposure to ultraviolet radiation, making sure that that
Yeah.
we're not burning the living shit out of ourselves when we go outside. You live in Florida, that might be a little bit more important for you than me.
Yeah.
Obviously, closer to the equator has more risks. Just protect yourselves. Doesn't have to be sunscreen. If you think sunscreen has endocrine disrupting agents in it, cool, fine, whatever. Put some fucking SPF protective clothing on. Wear a hat. We got options.
Yeah. What about, and I am interested in knowing your perspective on this because I don't know anything about this. What about the role of like community, social interactions, happiness, loneliness? Do those impact cancer risk?
I will say that it's hard to get definitive data on this, right?
Yeah.
Because human behavior is you can't control that stuff in an experiment, especially because a lot of our mouse models, the mice aren't humans, right? So like we can't realistically develop an experiment to test that. But what we can say from like a perspective of focusing on something like cortisol production, if we live in an environment where we're chronically stressed out because our friend group isn't great, all they do is go out and they drink, or they give us excessive stress just from like a behavioral perspective. Um, it's going to decrease our mental health and put us in positions where our overall quality of life will be poor. And so we can hyperfixate on the cortisol perspective. I just recently made a reel about this mechanistic implication between chronic stress in relation to cortisol signaling can predispose someone for cancer. So if they don't, have some sort of regulation of their overall cortisol, if maybe they don't go to therapy or they don't have some sort of medication sometimes, it can increase someone's risks for cancer just because they aren't dealing with their stress in an effective manner. Does that make sense?
Yeah, totally. I asked the question because as of recently, I've been really seeing the benefit of having like a positive and supportive community and environment for whatever it is you're trying to do, right?
Yeah.
And I know there's good science like showing like the effects of like depression on disease uh risk and things like overall life satisfaction and happiness, even though they're relatively subjective variables. But one, and this correlative for sure, but populations across the earth that have stronger like family bonds or a stronger community aspect um, seem to have uh, better longevity. So they live longer. And two, even just with like, I don't know. I don't know. I guess this goes into a completely different topic, but with I think this is intertwined with a lot of the other things that we're talking about being like healthy nutrition, healthy sleep. If you're surrounded about by individuals that also prioritize these types of things, you're more likely to do them. You're more likely to reduce your risk
Yeah.
of diseases, even though it may not be causative. It could be an influencing factor. Like the importance of just being in an environment that is conducive towards living the particular type of lifestyle that you're trying to live. I guess that's the perspective that I was
Yeah.
asking.
And I mean, that's something that I really strive for, especially on social media too, because honestly, social media, like it actually like outside of me enjoying making content and enjoying educating people, it stresses me out. Some days I just have to walk away from it because some people are just so hell bent on being trolls, man.
Yeah, man.
Um, and it's really sad because I put so much effort into just like trying to utilize my expertise as unbiased as possible to teach everybody independent of their walks of life. And then you have some jackass at the end of the day. It's like, Oh, big pharma pays your bills. You're a fucking loser. What the hell do you know? It's like my whole PhD in cancer biology just gets washed down the drain just because someone happens to pay my bills that they disagree with. I don't understand the logic there, but you can't teach people like that. And so one of the things that I, fixate on my page is trying to make a conducive environment for discussion such that now I just don't give those kinds of people space. I immediately delete their comment, or if they're being extra argumentative, they're just immediately blocked. I
Yeah.
often give people a warning like, hey, this is a page for discussion. If you have nothing productive to add or respectful to add in your discussion, see yourself out or you will be seen out by me.
Yeah.
And I found that my followers have learned to respect that, and they also operate on that same level. They don't comment on the bullshit most of the time.
Yeah.
A lot of pages I see even like on your page or even like, Dr. Ids, they'll just go and fucking have at it at people, start calling names on people.
Yeah.
But I like that I've been able to establish a place where people know not to interact with those people because it's only going to make things worse. Of course, it impacts my following. I don't have as many followers as you or Ids, but
I've also
I'd
told you
rather
this
have that
before, I think it's
environment.
because you have a very
It's
specific niche.
niche. Yeah, yeah. Cancer biology. It's not like people come to Instagram to learn cancer bio, for Christ's sake.
Yeah.
Nutrition is also a lot more prominent as well.
And yes, I talk about nutrition, but I talk a lot about weight loss and body composition, which like 99% of people care about to an extent,
Yeah,
So don't beat yourself up about that. I know you and I have talked about that
I
extensively.
know.
I don't think it has to do anything with what you're doing. Because I think what you're doing is, I told you this, absolutely fantastic. I think it has to do specifically with your niche, but that's fine because you're trying to educate the people that are interested in what you're interested in.
Yeah,
Like, it just, if you started a page on, I'm trying to think of something super, super, super niche, like the productions, the production of microplastics in like a particular product. Like that's all you talk about. You're not going to grow. For you,
yeah,
a small population of people that are really into the production of microplastics, and they're going to be
yeah.
engaged with your stuff. That's really what it is, man.
That's essentially what I've done on social media.
Yeah.
But yeah, you hope at the end of the day that people are going to be interested in cancer biology, and I'm still very, very thankful that I've been able to cultivate an audience of people that are, actually invested in learning the way that, both of us have gone about obtaining our education. So I think there's something to be
Yeah.
said about not patting myself on the back or anything, but also, yeah, I kind of am.
You should. I think celebrating success is an important thing.
Yeah.
I yeah, I don't like when people try to discourage others from celebrating themselves. There's a difference between celebrating yourself and then being like full of yourself. There's a big difference. And
Yeah.
it's
We
very
see
easy to
plenty
tell
of
that.
that.
I'm the coolest Joey around.
Yeah. Fuck you. Bullshit. Let's actually have a vote. We can have people vote on that.
You gotta have people vote.
Yeah.
Oh, Joe, I don't think you want it.
Who's the coolest Joe? Yeah. You have way more followers. It's unfair.
All right, let's wrap this up. Joe, where can people find you, my man?
I have an Instagram, mostly an Instagram. I have a Twitter. Don't really use it. I have a Patreon. People can look that up. If they feel like giving me $5 because I don't make any money on Instagram currently, kind of working on it on the back end. I just started a website, but haven't released it. So I'll be releasing a newsletter soon. People can see that link when I release it on my page in relation to my newsletter, which will probably be a monthly sort of thing because I don't have all the time in the world because I work a full-time job on top of what I do. But yeah, mostly Instagram.
The most important part, how do they find you on Instagram?
They just look for at Dr. Joe Zundell on Instagram.
Wait,
And oh, I didn't even know. I didn't say that.
you did not say that.
Goes to show you, I still don't know how to fucking communicate with people.
That I have an Instagram, and then you said the other ones, and that was it. So at
Wonderful.
Dr. Joe Zandell, there's a period between Joe and Zandell. As always, guys, all of the links to Joe's stuff will be down in the description of
No,
this
there's a
episode.
period between Doctor and Joe.
You're right. A period, just like my handle. So
Yeah.
dr.joezundell. Links will be down in the description. If you guys listen to the podcast this far and actually made it through all of our
It's almost
bullshit,
a Huberman podcast, dude.
almost. But all jokes aside, guys, thank you so much for listening. I hope you found some value in this episode. As always, if you're a regular listener and you enjoy the podcast, I only ask you to do one thing, and that's to rate the podcast and leave a review because it helps me a ton. It helps me reach more people with my content. Thank you so much, and I hope to catch you in next week's episode. See ya.
Peace.